Hi everyone. In today's challenge, we have a problem. The problem is minimum score of a path between two cities, and the problem number is 2492. Alright, guys. So now let's see what this problem says. After that, we will move to the logic and implementation part, right? So this problem says you are given a positive integer n representing n cities numbered from 1 to n. So basically, guys, first thing is clear that we are given the one variable that is n. That will be integer, right? So if n is 4, that means there are 4 cities exist. If n is 5, that means there are 5 cities exist, right? After that, it says you are also given a 2D array roads where roads of I is a of I and b of I and distance of I. So, but basically this means a of I, b of I, distance of I. Let's understand this, right? So we have a roads array. So let's say a roads has something on 0 index, let's say 1 and 4 and let's say 20, right? So basically this is a of I dimension, this is b of I dimension, and this is distance of I, right? Fine. So this is that this path exists between A to B. So 1 4 is basically the thing what we can say first city. 1 means a first city. 4 means fourth city, right? So that means there are a path between first city to fourth city. So we can say there is a path between first city to fourth city. So now guys, this is bi-direction. Like you can reach from 1 to 4 and you can also come to 1 by the 4. So that means you can reach from 1 to 4 and 4 to 1 also is, we can say, allow, right? So this is bidirection. So we can't write directional thing. So we can say this is bidirection. You can come from 1 to 4 and 4 to 1 as well. Now what is the distance between 1 to 4? That is nothing but this is d of I. So we can say there is a 20 unit of distance between 1 to 4. If you want to go from if you want to go to 4 by the 1, then you have to take 20, you can say, unit of time, right? Unit of time, we can say distance, right? It is a distance. So that is a clear one thing. There is a path between a to I to b to I and b to I to a to I with the distance of I, right? Now guys, it says the city graph is not necessarily connected. If n is 6, right? If n is 6, that means there are 6 cities exist. So it's not necessary that 6 cities are connected to each other. It may be the case that 3 cities are connected to each other and rest 3 cities are connected to each other. So the graph may not be connected, we can say, right? Completely connected. Now the score of a path between two cities is defined as the minimum distance of a road in this path. Now guys, this is the important line which you need to be understand. What is the score, right? So let's say I have n is equal to 4 right now. Let's take an example. I have n4 and first city is connected to second city is connected to third city, so it is not directional. So now first city is also connected to fourth city, right? So now you can see that 1 we can go to 2, 2 to 3, 3 to 2 also, 2 to 1 also, 1 to 4, 4 to 1 also. Now guys, this is going to be very important. Just try to understand this thing. So let's say this is nothing but 2, this is 5, this is 4, right? Now I want to find the score between 2 to 4. So tell me the score between 2 to 4. So what will be the score? That will be minimum distance of a road. So now guys, the score 2 to 4 is nothing but you can see that you can reach to 4 by just using this particular path, right? So what is the minimum? You can see that this is nothing but you are having a 2 unit of distance and then 5 unit of distance. So you have to find the minimum thing, that is nothing but 2. So you will say the score is nothing but 2. So that is nothing but the minimum distance, right? Now return the minimum possible score of a path between the cities 1 and n. Now what we have to do, we can say fix or clear there is a clear thing that we can say we have to find the score between 1 to the last n. N will be given to us. So if n is here was n4, so we have to find 1 to 4. And here the you will surprise that what is the answer of this particular thing, right? So now tell me there's like here is 5. So now 1 to 4, what is the minimum distance? What is the minimum score, right? You have to tell this. And you have to consider this three node. These three node are very important. And there's, if I have to tell you in short, then that means we can say one node you can visit n number of time. You can visit a city n number of times. You can come back to again and you can reach to that particular city again. That is not, we can say, they have given you restriction. You can reach n number of cities, n number multiple of times, right? So now 1 to 4, what is the we can say minimum score here in this particular example? Now you will say that there is only one path exists, so it will be 5, right? But it is not the case. The answer will be 2. How it's 2? You can see that we can reach to 2. Yes, isn't it? Because this is 1 is connected to 2, we can reach to 2. Now if you reach to 2, that means you have taken a 2 distance. Now comma. Now you can come 2 to 1 again. It's we can say bidirectional. So I come to 1, that is again took 2 unit of time, 2 distance. Now 1 to 4, I reach to 4 and I have took 5 unit of time. Now what is the minimum thing? You can see that. That is 2. So you are going to return 2 again. So now guys, I hope this is clear. This was the problem. Now let's move to the example and let's understand the example as well. So guys, in this example, you can see that this is a graph and what is the unit of, we can say, minimum score. So you want to reach from 1 to 4 and you can see that we can take this particular path, then this particular path, then this particular path. So it's going to take 5 unit of time, which is the minimum, right? 5 is the minimum distance, 7, 9, 5 and 6 out of these, right? Okay, now let's move to the next example. Here you can see that we want to reach 1 to 4 and you can see if I took this particular path, I have to give the answer 4. but there is a 2 as well exist. I can go to 2, then come back to 1, then come back to 3, then go to 4, and I have took nothing but 2 is the minimum distance, we can say minimum score, right? So this was the problem. I believe guys you understood by now. Now let's move to the logic part. What will be the logic? And guys, I will not take much time to understand the logic. So logic is simple, clear, that you have understood as well. So if graph is connected, and they have mentioned one more thing that guys you need to be understand here. The test cases are generated such that there is at least one path between 1 to n. Now guys, that is clear. By this line you must be clear that there's if there is one node exists, then there's somehow any how we can say there's n also exist with that particular thing, right? Because there is at least one path, right? So we can start our traversal from one node, and we are very much sure that by one definitely our n is connected, right? Now what we have to do, we have to find the minimum value of that particular connected component. If I have to say this particular thing, so I have to this you can see that if the is here was n is equal to 4, right? If I make 6, so let me draw this thing again, and I'm going to use same example but little variant. So 1 was connected to 2, or what was that, 2 and then 3, right? So 1 is connected to 2, then is 3, then is 4, right? So let me write here 4. Fine. Now if n was 6, so I could say that there is 2 is also connected to we can say 5, and let's say a node and 7, which would be better, and 6 and 7 are connected differently, right? So I'm going to start from 1 only, because I know that if n is 7, so I have to need to find the distance between 7, so I have to make sure that 7 is connected to 1, right? So I can say this is not, this is going to be 6 and this is going to be 7, right? So now I have say that I have connected all the components, right? There's 1, there's a 2, there's a 3, there's a 4, there's a 5, there's a 6 and 7, right? All the cities are present here. Now what is the different thing, that there are two component, different component, isn't it? But I am sure that if there is one exit, then there is n also exit, that is 7, right? They have mentioned already. Now guys, what I'm going to do, I'm going to start traversal on this particular component, not on this component, right? I don't care about this thing because I care about where the one node exists, or the starting node, right? So now I will start my traversal over this particular thing, and I have to just find the minimum value. So if there was value like 2, 4, 6, 8, so what is the minimum? 2, right? So I have to just find the minimum value, and that would be my answer, isn't it? So this was a simple logic, and how we can do this, that is a basic, we can use a DFS, we can use a BFS, doesn't matter, but in this we can say particular video we are going to use a DFS, right? So we are going to do a DFS depth first, we can say traversals, right? DFS we are going to use, and depth first search, and what we are going to do, we are going to find the minimum value and we are going to return that particular value. Now let's see how we can do this with the implementation part. So let's move to the implementation part. So first of all, what I'm going to use, I'm going to use a Python, then I will move to the C++, then Java, right? So let's see what we can do. We can, first of all, what we have to do, I have to maintain a adjacent list. So for adjacent list, what I'm going to do, I'm going to say adjacent list is right now collections dot default tip and off list, right? And I'm going to traverse over road for A, B, and there is C as well in roads. And it will be better if I use a D, that means distance. Now fine, what I'm going to say, I'm going to say adjacent of A dot append. What do you have to append? You have to append B with a D distance. Same thing you are going to do with a B as well. Adjacent of B append A with the D distance. Once you are done these things, what you are going to do, you are going to say I have prepared my adjacent list. Now let's use a define solve a function which you're going to use. We do nothing but DFS only. So there's going to be node and it's going to be is visited set. Fine. And if is visited is already, we can see if node is already is visited, that means we have already explored that particular city, right? So we don't need to do explore it again. So we can say return the max value. So we can return the floor of infinity, right? It's going to be return the maximum value. If it is not explored already, so we are going to explode it, and we are going to say result is going to be first of all let's put in set. So we are going to say is visited dot add this node, we have explored it now. Now once we explore it, we are going to take that particular, we can say the distance. So we can say result is going to be, so what is going to be the distance between the previous node to this particular node, right? So what I can say, currently it's float of infinity, right? It's currently infinity, but I'm going to traverse over all the childs. So if I take you with an example, see if I am here at one, example one, you can focus. If I'm at one node, so now I have to find out how many nodes there exist, how many, we can say child, or we can say how many other connected, we can say a neighbor node exist, right? So there's 4 and 2 are the neighbor nodes of 1. So I'm going to just find out their distance, and I'm going to find out the minimum distance after them, right? So there are 2, 7 and 9. So what will be the minimum? That will be 7, right? So same thing I'm going to do, I'm going to say for child and distance in adjacent list of this particular node. So I'm going to say just first of all result is going to be minimum of distance and result, right? So this will take 7 comma 9, that will be minimum 7. First of all it could be 7, and 7 comma infinity is 7, then 7 comma 9 is 7, right? After that it's going to say result is going to be minimum of result. Now let's call for the this particular, we can say particular node, right? So I'm going to say solve this particular child, and you can pass is visited, right? So once this is done, so you are going to return at the end return result. So this is nothing but we can say simple DFS. Once this result will return, we are going to call this function with a one node, and set is going to be empty right now, and return this particular thing. Now let's run this code and see whether it's working fine or not. And you can see that both the tests are passed. So let's try to submit this code. Guys, logic was quite easy. Implementation is also easy, isn't it? And you can see that it's successfully accepted, right? So we have successfully solved with the Python. Now let's move to the C++. And yeah, it will take a little time with C++ because we have to create a adjacent list, and that is really a hard thing. Vector, then we can say pair of int. All right, so this is nothing but adjacent list. Once this is done, we are going to give a name adjacent. After that, we are going to say take a default value of n+1, where is going to be nothing but vector, and you can say vector of pair, right? Pair of int comma int. So fine, and here you can say 0 comma -1 -1. So we have given the default value as well, right? So but the size is 0, doesn't matter, right? Now once we are done this, we are going to create a, we can say array, which is visited. Either you can create a set. In Python it was easy to maintain a set, right? But in C++ it's easy to maintain a, we can say array, right? So I'm going to say bool data type, or you can create a vector. So I can say vector of bool data type, and the name I'm going to give is visited, and here it's the size is going to be nothing but n+1, right? Why n+1? Because we are starting with one node, right? So we can say I have to get the index of n as well, right? So n+1, and by default the value is going to be false. Now once this is done, so we are going to say just maintain an adjacent list. So what I can do, I can say for auto, we can say data in rows, I can say adjacent of the data of 0, right? Data of 0 dot push back. What I can say, what I can push, I can say push back this particular data of 1 comma data of 2, right? And same thing I can do with a 0 as well. So data of 0 comma data of 2 and data of 1 here. So we have created an adjacent list. Now once we created an adjacent list, we are going to call a function, and that thing we are going to return. So we're going to return soul of that particular function with a one value, and we have to pass our adjacent list. We have to pass our, we can say this boolean thing, right? Is visited. So we have done this, and we are going to create this particular function. So let me create this thing. I'm going to say is visited, not is visited. I have to say what the data type will be. The data type will be integer, so int, and this going to be the name soul, and first of all the node int node. Then what I'm going to take, I'm going to adjacent list. So let me copy this thing. Fine, I have taken this thing. Now once this is done, I'm going to take a is visited vector of bool is visited. Once this is done, what I'm going to do, I'm going to say if is visited of this particular node is already true, so return the max value into max. But if it is not true, so make it true. Is visited of node is going to be nothing but true. Once this is true, I'm going to say my result is going to be nothing but into max. I have told you why it is so, because we are going to traverse now all the neighbor nodes. So we are going to say for int of array of child, or we can say neighbor, is going to be nothing but neighbor. Let's give it a neighbor in adjacent list of that particular node is going to be nothing but, we can say result should be the minimum of itself, and the neighbor of, we can say 1, because 1 is nothing but distance, and result should be the minimum of itself, and this function solve neighbor of 0, that is nothing but the neighbor node, and adjacent list will be same and is visited, right? Fine, and now we are going to return nothing but result. Now guys, see, this is going to give you TLE. Why? Because we can see that we are not passing it by a reference, so it's better to pass by reference, and is visited is mandatory, right? If you don't pass it by reference, this adjacent list, then you may get an TLE, but is visited you have to pass it mandatory. It is mandatory to, we can say, work this particular function, and you have to, if you have to pass this also by path by we can say the pass by reference, right? Once this is done, let's try to run this code and see whether it's working fine or not. And you can see that we got an error that is nothing but, okay, so we are getting said in place of bracket. Okay guys, so we have taken a first, you can see that this is nothing but, we can't take an array, right? So this is nothing but pair, so we have to use a dot first and dot second, right? So I can say for 0 I can say dot first, and for 1 I can say dot second. So this was the nothing but pair, right? Now let's see. You can see that both the test cases are passed, right? Now let's try to submit this code, and you can see that, let me see why it's taking so much time. Yeah guys, you can see here we have successfully submitted with C++ as well. Now let's move to the last programming language, that is nothing but Java. And what I'm going to do, I'm going to first of all create a JSON list. So I can say I can give a variable data type list. After that, integer data type, and then we can say a list, right? So give adjacent list. So what basically I'm doing here, I am creating a list. First of all, list itself is an array, and it also contain inside also an array. I hope this makes sense. Now I'm going to say this is going to be nothing but new array list of n plus 1 size. So this is nothing but an array, right? Now I'm going to say for int I is equal to 0, not 0, I is equal to 1, I less than n plus 1, and I plus plus. What I'm going to do, I'm going to say adjacent list of I should be new array list. And now I'm creating a that particular array list, right? Fine. Once this is done, what I'm going to do, I'm going to say create a boolean is visited array. I hope this you already know. Boolean, we can say like this, is visited, and new boolean, what is the size will be n plus 1. Now once this is done, I'm going to create adjacent list. So I'm going to say for I can, what I can do, I can say this is going to take integer, we can say data is going to be rows, and I'm going to say adjacent list of data, right, of 0 dot add adjacent list on. Here you have to pass an array, so you can say new int, and here adjacent list or not adjacent data of 1 comma data of 2. I hope it makes sense, right? So once this is done, I'm going to do with the, it is a bidirectional, so I have to do with 1 as well. So I am going to write here 1, and here I'm going to write a 0. Alright guys, so we have created adjacent list also. Now what we are going to do, we are going to create a function. So we are going to say, let's create a function here. So the function name I'm going to give it is public int sol, and here let me write sol, and here I'm going to say node. Then I'm going to get my adjacent list. So let me copy this here, data type. Fine, and here I'm going to say a boolean array, right? So boolean is visited. Fine. Now once this is done, I'm going to check it. If it's visited of node is already true, so return max value. So we can say integer dot max value. So let me write here max value. Fine. Now once this is done, what I can say, let me write here it. What I can say make it true, right? Is visited of node, make it true if it is one not true, right? So what it will do, it will say that we have explored this particular node. Now no need to explore again, right? Once this is explored, we are going to create a function variable result, which is going to be currently integer dot max value, means a maximum value. Now we have to find the minimum value, right, out of this path. So what will be the minimum value? How you can find it? You can to traverse to your neighbor node. So we can say for, what I can say this is nothing but an integer, right? So we can say integer of child, or we can say neighbor of their adjacent of node, right? So we're gonna say result should be the minimum. So we can write math dot main result comma, and what we can say neighbor of one is containing the distance part, isn't it? And same thing we are going to do for a nested neighbor node. So we can say result should be the minimum of result comma, call this function again solve, and here you're going to pass your neighbor of 1 0, because this is a node and 1 was the distance. Now 0 comma you have to pass here adjacent same, and is visited also same. In Java you need to pass a path file, we can say reference, it's so by default. Fine. So once this is done, you are going to return result, and you can say that let's use this function inside this miniscore function. So we are going to say sol, and node is 1, and adjacent list we have already created, is visited we have already created, right? Fine. And we are going to return this particular thing, whatever the thing which is going to return by this particular function. Now let's see whether it is working fine or not. And here we got an error by, because we haven't used a semicolon. Very, we can see that basic error, right? Okay, now do we have any error? No, you can see that it's successfully accepted, right? So now let's try to submit this code as well, and hopefully I believe it should get submitted. And here we go, right? You can see that it's successfully submitted. Now guys, I believe guys you have seen the implementation of C++, Java and Python. If you still have any kind of doubt, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.